Only bad kids.
They're stupid.
I know.
Oh.
I'm so glad that didn't fall on you. Nothing that I did. It's not my fault. All right, now try not to move, okay? All right. Okay, here we go. We are ready for number 2E. So we remember from yesterday, let's do a quick review of yesterday to get ourselves back in here. All right, you don't need to write this down. I'm just doing a quick review. Here we go. Everybody paying attention?
Yep.
So we have something like this. All right, so remember we draw a number line and we put a number right in the middle of the number line.
-3.
The number that goes in the middle of the number line is the opposite of that number, right? And then we count, and I put 2 dots on the number line, and we count back and forth. How many? 4. So this would be at 1, and this would be at -7.
Yep.
And then we look at the sign, and if it's greater than, we shade out. It's greater than, so I'm going to shade out. If it were less than, I would shade in between the 2 dots. So my answer is -infinity to -7, or 1 to +infinity. Everybody good with that? Remember that from yesterday?
Yep.
Okay. Then we also looked at problems yesterday like this. This could be exactly the same problem too, I don't even remember. And how did we do these? They look different. See, this is a different kind of problem. So what's our strategy on that one?
Factor.
We factor it. What?
X minus 5. X minus 1.
Plus
1. Plus 1.
All right, then I draw my number line, and I'm going to put 2 dots on the number line again. Where are those 2 dots going to go? At -1 and +5 in that order?
Yeah.
You.
Now what do I do?
You pick a number.
Pick a number. And it doesn't matter what number I pick, as long as it's not -1 or 5. I have to pick a different number than those. So Deshani, what do you want to pick? 10.
12.
All right, here's 10. 10's out here. So I'm going to put 10 in. When I put 10 in, I get 10 minus 5 times 10 plus 5, or 10 minus 5 times 10 plus 1, which gives me 55, because remember, those are being multiplied. Is 55 less than 0? No. Less than 0 means negative. So this is not shaded. It didn't work. Which means this part is shaded and this part isn't. So your answer is all the numbers between -1 and 5. Your hand up, sweetie.
It might be wrong here, but would the circles be filled in?
They would be. Thank you, Quincy.
You're welcome.
They are filled in. Why are those circles filled in?
The line.
Because it's an or equal to. Okay? Now we're ready for E, which is a little bit tougher problem, but it's just like the one I just did. The only difference is we can't jump in and factor like this yet. What do we have to do first? Joseph.
I have to take out an X.
We do have to take out an X. So out comes an X. Every term has an X. We call it the GCF, greatest common factor. So out it comes. We have x squared minus 2x minus 8. Is that okay with everybody?
Yes.
Now what am I going to do with the x squared minus 2x minus 8? That I'm going to factor. So bring the x along. Don't get rid of the x. You got to keep the x. And then the 2 factors. Althea, you got any ideas? Okay, well, let's look at it, see if we can figure it
X
out.
minus 4, X plus 2.
So we're gonna have x's.
X minus 4 plus 2.
Well, thank
X
you.
minus 4 plus 2 minus?
X minus 4 plus 2, because negative 4 and positive 2 added together make negative 2 and multiplied give me negative 8. And what's going to be different about this number line?
Facts.
There's going to be 3 dots. And I know everybody knows there's a dot at 4 and there's a dot at negative 2. Where's that dot? 0. Very good. If there's no number attached to it, if it's just a plain X, then the dot is at 0. Joseph, your hand up?
Yeah, where's the 0? Like, is it just the X?
Yep.
Okay.
It comes from that factor right there. If you have a factor of a plain X, it's always going to be 0.
Alright.
So I have 3 dots, and Quincy, this time they are open. Would you agree? Okay. Now I'm going to pick a number, and I can pick any number I want.
1.
1, I can pick 1. 1 is in here. Now when I put 1 in, look. When I put 1 in, I get 1, negative 3, and 3. Would you agree with that? When I multiply those together, I get negative 9. Is negative 9 greater than 0?
No.
No. Which means this section is not colored. Which means what about this section?
No.
It is. And this section,
Yep.
it is. And this section, it's not. I have 4 sections this time. Marley, you okay?
Yeah.
Paul?
Why do we not shade to the left of -2 and -9 over
Okay, wait. No, these are X values. I'm shading X values. X was 1 when I put 1 in. The negative 9 is not an X value. It is the number this actually equals. It's the number that has to be greater than 0. So my answer, -2, 0, union 4, infinity. All right, F, here we go. All right, Althea, now we're going to give you a chance. Everybody else be quiet, let Althea talk. You got an idea for this guy? Yep. And that will leave me with what, Althea? X squared. Not minus 0, 1. Yep, we need a placeholder, so the placeholder is 1. Remember, when you distribute it back, you should get what you started with. So you need a 1 there, so you'll end up with an X if you multiply it back together. What about this?
Difference of squares.
Difference of squares. And how does the difference of squares factor?
X plus 1, X minus 1.
X plus 1, X minus 1. Beautiful. So once again, I've got 3 dots on my number line. This time they are closed. And where are they?
Positive 1.
0,
1.
negative 1, and positive 1. Make sure you put them in order. Now pick any number you want that's not these.
7.
7. If I pick 7, 7's out here, right? So here we go. That would be 7. I'm putting 7 in for all the X's. So 7 times 8 times 6. Now, I don't know what that is. It's some big number that's positive. Do you agree with me?
Yes.
Yeah.
Is it less than 0?
No.
No, it isn't less than 0, which means I'm not going to color that section, which means I will color this one and I won't, and I will. So I picked a number, you picked a number, and it didn't work. That means here they will, here they won't, here they will. So negative infinity to negative 1. Remember, the infinities always are open, union with 0 to 1. Wouldn't surprise me one bit if the next time we were together we had a little quiz that had a couple of questions on it, and one question would be one of those absolute value things we did first, and one would be one that looks like this. Okay? So we practiced quite a few. Paul?
Just those things or P1?
No, just those things. Okay? Now, number 3. This is projectile motion. I will always give you the general formula for projectile motion. However, that's the general formula. You will be responsible for being able to write the actual equation for each specific problem. Here's how it works. In this formula, S of t stands for the height. So sometimes kids just say, Mrs. Ford, I know I'm a math student and I'm supposed to use function notation, but can I just say h? And the answer is, of course you can. That's what it stands for, the height. T stands for the time in seconds. So what projectile motion is you got Quincy throwing a ball. This formula is going to tell us how high the ball is above the ground after 3 seconds, or 1 second. Okay, that's what this formula does. It tells us how high the ball is. V sub naught, and that's how we read that, V sub naught, or V sub 0, is the initial velocity. So when Quincy throws the ball, he puts some force into it. That's called velocity. And it's usually measured in feet per second. Your car, it's measured in miles per hour. And if V sub naught is the initial velocity, what do you think S sub naught is? The initial height. So for Quincy, when he lets the ball go, it's just about 6 feet off the ground.
Ooh.
Right? Just about. When they launch fireworks at the fireworks show, they launch them from the ground. What would be the initial height when they launch those up into the air? 0. It's on the ground. Sometimes that number is a 0. Okay? This number can actually also be a 0. Think of this situation. I'm going to go to the Walsh Activity Center up on the balcony, and I'm going to take a tennis ball, and I'm going to drop it over the side. Obviously, that ball's going to move, right? It's going to go down. But when I release it, I'm not throwing it down. I'm just opening up my hand, and it's falling out. The initial velocity is 0. I have provided no force. It's just dropping. So both of these numbers can at times be 0. If this is 0, you are launching from ground level. If this is 0, you are dropping the ball. Asia, you taking notes back there? You better be. better not be a note to somebody. Unless, of course, you're telling them how awesome projectile motion is. When will, oh wait, a ball is thrown off the top of a building 12 feet tall with an initial velocity of 18 feet per second. All right, tell me my equation. H equals negative 16t squared plus 18t plus 12. Now kids, do y'all understand where the 18 and the 12 came from? They're right there in the problem. Why did we put the 18 in this spot? It's the initial velocity. I mean, it just says it. The initial velocity is 18. And why did we put the 12 here? The building that we're throwing the ball off of is 12 feet tall. So it's starting 12 feet up in the air.
Where does the S times T come from? Like,
That isn't S times T. That's function notation, like f of x.
okay, like what is that? Like,
It means S of t. It means the height at time t. Physicists, for some reason, use S as the letter for distance. So this is the height at time t. But I'm thinking of it just as h. How many of you remember last year when your teacher said, okay, we've got this function notation, f of x, but if you'd rather call that y, it's the same thing. Remember that? So S of t, if you'd rather call it h, you can. Just like f of x was y, S of t can be called h, because it means height. That might help you remember it means height. So this is the equation I'm going to use for my problems. All right. When will it hit the ground? So I have thrown the ball up into the air, and eventually it's going to hit the ground. Agreed? Okay. When? Now, look at your equation. How many variables does it have? 2. One of your variables is h, which stands for height, and the other one is t, which stands for time. Now, you're always going to be given one of them. So in this problem, when will it hit the ground? They either gave you a time or they gave you a height. Which did they give you in this problem? You need to read it and think about it. Did they tell you a time or did they tell you a height? What height did they tell you?
12 feet.
No. I'm talking about in the question itself, in letter A. We already put the 12 into the formula. Letter A. What did they tell you? When will it hit the ground?
0.
If it's on the ground, isn't its height 0?
Yeah.
So 0 equals negative 16t squared plus 18t plus 12. Now, some of you are looking at me because you can't stand word problems and you've given up already. You can't. You need to know how to do this problem. Always, you're going to have either h or t in the question. And you're going to plug it in wherever it fits. If the ball is on the ground, then its height is 0. So I can use 0 in for h. Now I'm going to solve this equation. Do you have any thoughts on how we might solve that equation?
Subtract 12, yeah.
You could, I probably wouldn't.
Divide by 2.
Well, I love, somebody said divide by 2. I would actually divide by -2. I love that. It is not mandatory. You don't have to do it. What it's going to do is make your numbers a little more manageable. You don't have to do that. That is an optional step. I would do it, but it is an optional step. How do I solve that kind of equation? It's an equation with a squared in it.
Factor.
I factor it. What if it doesn't factor?
Quadratic.
I'll use the quadratic formula. This does not factor, so I'm going to use the quadratic formula, which is negative b. Let me write down. So my a is 8, my b is -9, and my c is -6. So negative b would be 9.
-9 squared.
Now when I square negative 9, I get positive 81. Some of you are still putting negatives in there. That's 81 minus 4 times 8 times negative 6, all over 16, 2a. All right, I am not up for this. So 81 plus 4 times 8 times 6. I got the square root of 273. Anybody else get that? Remember, this becomes a plus. So 81 plus 32 times 6. Anybody match 273? Okay, now you know I already made one mistake today. You can't just trust me. You have to keep an eye on it. Alright, so I'm going to get two answers. 9 plus the square root of 273 over 16. And 9 minus the square root of 273 over 16. So I'll type those into my calculator. Now caution, 9 plus the square root of 273 equals divided by 16. Make sure you get equals. So this is about 1.6. 9 minus the square root of 273 equals divided by 16. This is about negative 0.5. And everybody's turned the page. We got an issue here. We have a big issue. What is the question again? What am I answering? When does it hit the ground? Does anything bother you about those answers? What's the deal with that negative one? Well, you really shouldn't be talking about negative time. Let's look at the situation. Here's the building, 12 feet tall. Here's the ball. I threw it up in the air and it hit the ground. Right? Now, that is the only answer to the problem. 1.6 seconds. But mathematically, is there another point when it's on the ground? Mathematically, not in real life, but from the math standpoint, isn't there another point over here where it's on the ground? And that's your negative 1/2, but that one doesn't count in this problem because the ball started right here. So this is what we call those answers that are no good? We ran into them the other day. Remember, what do we call them? Extraneous. This is another example of an extraneous root. We didn't make any mistakes. It's perfectly okay, except it doesn't make sense in the problem. I gotta keep my equation here because I'm going to use it for the next problem, which is, when will it be 15 feet above the ground? So look at my picture. I've thrown the ball up into the air. Here's 15 feet. When will it be 15 feet above the ground? Now there should be two places that is 15 feet above the ground, right? Once on the way up and once on the way down. Here's our equation. Question is, when is the ball 15 feet above the ground? So tell me what I'm going to do. When is the ball 15 feet above the ground? 15 is the height. 15 goes in for one of the variables. You're exactly right. Does everybody understand why I put it in where I put it? You have two variables. We're putting the 15 in for h because height's a height. All right, let's solve it. Austin, what do you think, sunshine? How would you solve that equation? Actually, I'm going to go the other way. I want to get a 0 here, so I'm going to subtract 15. When I solve a quadratic equation, I like to have a 0. So I'm going to move my 15 over. Okay? Now, does anything divide out of that?
No. Yeah. No. No.
Nothing divides out. If you want to divide by -1, you can, but no other number divides out, right? So I'm stuck with it. A equals -16, B equals 18, and C equals -3. Now, thank goodness I have a calculator. Here we go. T equals -b plus or minus the square root of, okay, is that 324? 18 squared, I should remember that from like 3rd grade. 324, yeah. B squared minus 4 times A times C, all over 2A. You know, there aren't many good things about cancer, but one of them is I can always blame chemo brain when I forget stuff. All right, so let's clean up what's under there. Now notice, how many negatives do I have?
3.
So these two will cancel, but that's going to stay a minus. So I got 132 under there. Anybody else get 132? Why do I feel like I'm talking to myself this afternoon?
It's been a long day.
True.
But you're ending it the best way you possibly can.
Can't think of it. You're right.
Think about those poor losers that didn't have math today at all.
I know, it's crazy.
I know.
Feel sorry for
I'm
them.
glad I have math today, Miss Ward.
Yeah.
They're having a bad day. All right, so here we go. I hope that's a 132. Nobody corrected me, so I'm going with it. So -18 plus the square root of 132 equals, divided by -32, I got 0.2. About 0.2, I'm rounding off. -18 minus the square root of 132 equals, divided by -32, that is about 0.9. So I'm going to come over to my picture, and it said, when is the ball 15 feet above the ground? And you figured out that it was 0.2 and 0.9. And what's the unit on that? 0.2 seconds and 0.9 seconds. Perfect. Perfect, perfect. And then question C. And again, right here's my formula. This is the formula you're using for every one of the problems in this set. A, B, and C. How high is it after 1 second?
I have a question about the previous problem.
Okay, let's answer this one. How high is it after 1 second? What am I going to do? I'm going to put 1 in where? For the height or for the time?
Time.
It's 1 second. So I'm going to put 1 in, so that'll be -16 plus 18 plus 12, which adds up to 14 feet. So after 1 second, it's 14 feet tall, or 14 feet high. All right, Swanton, what's your question?
Did you say that the answer for B was the 0.2 or 0.9?
Both.
Both?
Look at your picture. Isn't it 15 feet above the ground on the way up
Yeah.
and on the way down? They're both fine.
Okay.
We expect 2 answers. Well, yeah.
Where's it?
All right, number 4, here we go. We're almost done. A rock is thrown from ground level with an initial velocity of 32 feet per second. So the first thing you have to do is write your equation. Now, here's the general form, and you need to create the equation for this particular problem. A rock is thrown from ground level.
0.
So where? What 0?
Height.
No. Be careful, I'm building my equation.
So
Height
ST.
equals negative 16t squared plus something.
0. Initial height.
So 30.
Yeah, this is 0. That's the initial height. And if we're throwing from ground level, the initial height is 0.
Okay.
What about the 32? Where does it go?
Velocity.
It goes here. So I have plus 32t, and then really just plus 0? I'm not going to put it. It confuses me, but if you want to put it on there, you can. When will it hit the ground? All right, now this is our equation, kids. This is always going to be an h. This is always going to be a negative 16t squared. You stuck in numbers here, right? Just put it in the plate. Now, when will it hit the ground? On the desk, the table, the yellow plate there. When will it hit the ground? You're going to put in a number for h, or you're going to put in a number for t? Which one? When will it hit the ground?
T.
You're going to put in a t value? If it's on the ground, isn't its height 0? On the ground, height 0. Now, we can divide everything by negative 16, can't we? And that really helps. I divide everything by negative 16. Over there I couldn't divide, so I had all that big arithmetic, but this is simple. In fact, that factors, doesn't it? So what are my answers? T equals 0 and T equals 2. So this ball is on the ground at T equals 0 and T equals 2. Now, remember, kids, this ball was thrown from ground level. It's on the ground twice. When it starts, that's T equals 0. And when it hits the ground, which is T equals 2. How high will it be after 1/2 second? How high will it be after 1/2 second? This is your equation. You always come back to that. They gave you a 1/2. Does that go into the H or does that go into the T? T, it's a time. So H equals negative 16 1/2 squared plus 32 times 1/2. Now I'm going to do this without a calculator because I can. I'm old. 1/2 times 1/2. Times, not plus, times. 1/2 times 1/2. 1/4. Times negative 16. 16 times negative 1/4. Negative 4. Plus half of 32. 32 times a half. Half of 32. 16. I get 12 feet. Yeah, you can type that in your calculator if you wanted, but you better get 12, because that's the right answer. How high is the ball? After 1/2 second, it's 12 feet tall. Last question, and we're done with the note sheets. Big celebration. When will it be 20 feet high? When will it be 20 feet high? Come back to your equation. The 20 goes somewhere. H, because that is a height. So we have the equation 20 equals negative 16t squared plus 32t. How do we solve it? Subtract 20. Remember, you gotta have it set equal to 0 before you can mess with it. Can we shrink this one down at all? Divide by -4. Now again, you don't have to do this. I like to do it because it makes my numbers more manageable. But it doesn't change your answer at all. Doesn't factor. So t equals, here we go, negative b plus or minus the square root of b squared minus 4ac. Some of us still haven't learned our quadratic formula. We're going to get that learned. All over 2a. Oh, wait a minute. I'm not sure I like what's going to happen there. What's going to happen there?
Negative.
I got a negative under that radical sign. Tell me about that. What happens when I have a negative under a radical? I get an I. Now, time out. What was the question? When will the ball be 20 feet high? And you got an imaginary answer. This turns out imaginary. What do you think that means in terms of my ball? Huh? It never gets to 20. 20 is up here, and our ball never gets that high. So the answer to the question is, it doesn't get to 20. It never gets 20 feet tall. You put, it doesn't get to 20 feet tall. It doesn't go that high, because the answer you got turned out to be imaginary. And that doesn't make sense in terms of the problem. Okay, hey, you can't go anywhere, we're gonna stay for the blessing. Okay, so we don't have class tomorrow, so on Monday.